The question says that two large thin metal plates are parallel and close to each other. On their inner faces, the plates have surface charge densities of opposite sign and of magnitude 17 times 10 to the power minus 22 coulomb per meter square. So the configuration is like this. There are two plates. I have symbolized them as red and the black one. They are carrying opposite charges of charge density sigma equals to 17 times 10 to the power minus 22 coulomb per meter square. We have to find out what is the electric field in the outer region of the first plate, that is this region, outer region of the second plate, that is this region, and between the plates, that is this region. Now we can leverage the Gauss law in this, which states that net flux from any surface is equals to Q enclosed, that is the charge enclosed in that surface, divided by epsilon naught. Now flux is given as E dot ds, or the dot product of electric field and the area vector. Now the geometry in subject is of thin metal plates parallel to each other. Now we can assume it as like this. Now we can assume the Gaussian surface to be of a parallelopiped like this one in the green box that we can see. Now the electric field due to this thin metal plate would be parallel to these all four faces, this one, this one, this one, and this one. So they won't contribute to the electric flux, because we know that dot product angle between them would be 90 degrees, so it would result out to be 0. Now the flux due to this number 1 phase and number 2 phase will be counted, and they both will add up to 2EA. Now A would be the area enclosed of this surface. Now sigma A would be the charge enclosed in this parallelopiped. Now this flux, this is quantity is flux, and this is the charge enclosed divided by epsilon naught. Now from this we can know that E is equals to sigma by 2 epsilon naught. So for this region of our interest, that is away from both of the plates and near the first plate, we can make a Gaussian surface that would enclose both the charges, and thus they both are having equal and opposite surface charge density, and since Gaussian surface is enclosing both the plates, so the net charge would be 0. So electric flux due to both these metal plates at point A would be equal to 0. Similarly at B it would be equal to 0, and at C it would add up because they both are of opposite charge, and Gaussian surface of this would result EA. Gaussian surface of this positive plate would result the electric field as sigma by 2 epsilon naught. Similarly by the negative plate it would result out to be sigma by 2 epsilon naught, and they both will be of same direction, from away from the positive charge and towards the negative charge, like this one. Now they both will add up, since the angle between them is 0, so they both will add up, and the vector addition would be sigma by epsilon naught, and this would give us 1.92 into 10 to the power minus 11 Newton per coulomb. Thank you.